Let's solve this spectra. So we have a molecular formula of C4H8O2, and we are going to walk piece by piece through the fragments, through these peaks, and figure out what is going on. So if we take this first one right here, we've got 3 hydrogens, so we know it's a CH3 group, and we can see that it's a triplet, so n plus 1 equals 3. 3 minus 1 is going to be 2. That n tells us the number of neighboring hydrogens. That's why it's a triplet. So this is a CH3 next to a CH2 group. Let's go to the next peak. So this is also a CH3 group. If we can see it's a singlet, so n plus 1 equals 1 because it's a singlet. 1 minus 1 is 0. So this CH3 has a carbon with no hydrogens next door. Let's go to the last peak right here. We can see this is a quartet, so n plus 1 equals 4. Obviously, 4 minus 1 is 3. So next door to the CH2 group is a CH3 group. Now we're going to notice that we have 2 fragments. Both of them have a CH3 next to a CH2. Those are obviously the same fragments because we only have 4 carbons. So the 2 fragments that we're working with now are a CH3 next to a CH2 and a CH3 with a carbon with no hydrogens. Now check this out. Remember in part 1 we talked about if we have a peak between 2 to 3, that is going to be an sp3 next door to an sp2 hybridized atom. So if we look at this, we've got 2 oxygens, so it's not just going to be a CH3 next to a C, it is going to be a CH3 next to a double bonded oxygen. So the 2 fragments we're working with now are CH3 next to a CH2. We have a CH3 next to a C double bond O. We've got 1 oxygen left over. That is going to account for 2 attachment points. So now we can see we have an oxygen with 2 attachment points, and we have 2 fragments. So all we're going to do is line them up, click them together, and we now have solved the NMR.